What lurks at the heart of a black hole? Is it a gateway to another universe, a cosmic dead end, or something so bizarre our current science can't even comprehend it? Today, we journey to the ultimate frontier, to a place from which not even light can escape, the event horizon. And we ask, what happens if we go beyond? Welcome to the Cosmic Question, where we explore the most profound and perplexing enigmas of the cosmos. Today, we're venturing into the truly forbidden territory of black holes, exploring theoretical possibilities like white holes, wormholes, and the very nature of reality at its most extreme. This is a journey to the edge of known physics, and perhaps beyond. The black hole basics, gravity's ultimate triumph. Before we can speculate about what's beyond the event horizon, let's briefly recap what a black hole is. Formed from the cataclysmic collapse of a massive star, a black hole is a region of space-time where gravity is so incredibly strong that nothing, not even light, can escape its pull once it crosses a certain boundary. This boundary is the event horizon. Think of it as a cosmic waterfall, and the event horizon is the point where the current becomes too strong to swim against. Once you pass it, you're inevitably drawn towards the center. General relativity, Einstein's theory of gravity, tells us that all the matter that formed the black hole, and anything that subsequently falls in, is crushed down to an infinitesimal point of infinite density at its very core. This point is called the singularity. The singularity, where physics breaks down. This concept of a singularity, a point of zero volume and infinite density, is where our current understanding of physics, specifically general relativity, admits defeat. Infinities in physics usually signal that the theory is being pushed beyond its limits of applicability. To truly understand what happens at a singularity, we'd need a theory of quantum gravity, a theory that successfully merges general relativity with quantum mechanics. We don't have a complete and verified one yet, though candidates like string theory, which we've discussed before, offer potential pathways. So when we ask what's beyond the event horizon, we are, in part, asking what happens at this singularity. Is it truly a point of infinite density, or does new physics, quantum physics, take over at such extreme scales, smoothing out the singularity into something else, something perhaps less singular? Beyond the veil, theoretical possibilities, the forbidden zone. This is where speculation, grounded in theoretical physics, becomes truly tantalizing. If we could somehow survive the journey past the event horizon and towards the singularity, which, for a stellar mass black hole, would involve being torn apart by tidal forces in a process gruesomely called spaghettification, what might we find? One of the earliest theoretical explorations led to the concept of a white hole. Mathematically, a white hole is like a time-reversed black hole. While nothing can escape a black hole, nothing can enter a white hole. Matter and light can only flow outwards. It's an intriguing idea, a cosmic ejector seat, but most physicists consider them highly unlikely to exist in our universe. There's no known physical process that could form one, and they would be incredibly unstable. If they did exist, they'd be pouring out energy and matter from where and from when. Then there's the even more famous concept of a wormhole, or an Einstein-Rosen bridge. This is a theoretical tunnel or shortcut through space-time, potentially connecting distant points in our universe, or even connecting our universe to another, entirely different one. The mathematics of general relativity allows for solutions that describe wormholes. However, for a wormhole to be traversable, stable enough and open long enough for something to pass through, it would require the existence of exotic matter. This isn't just matter we haven't discovered yet. It's matter with bizarre properties like negative mass or negative energy density, something we've never observed and aren't even sure can exist. So, while mathematically possible, practical, traversable wormholes remain firmly in the realm of science fiction for now, though they continue to inspire theoretical research. The information paradox: does anything truly escape? The journey beyond the event horizon also throws up one of the deepest puzzles in modern physics, the black hole information paradox. Quantum mechanics dictates that information can never be truly lost or destroyed. It can be scrambled, hidden, or transformed, but the underlying information content must, in principle, be recoverable. However, black holes seem to violate this fundamental tenet. When something falls into a black hole, its information appears to be lost to the outside universe forever, trapped beyond the event horizon and ultimately crushed at the singularity. Even when Stephen Hawking famously showed that black holes aren't entirely black, they slowly evaporate over vast timescales by emitting what's known as Hawking radiation. This radiation initially seemed to be purely thermal, carrying no information about what fell in. This paradox has led to decades of intense research. Does the information escape somehow, perhaps subtly encoded in the Hawking radiation as the black hole evaporates? Or is it stored in some other way? Or does general relativity or quantum mechanics need a fundamental revision at this extreme interface? Recent ideas, like the holographic principle or concepts emerging from string theory like fuzzballs, suggest that information might indeed be preserved, perhaps encoded on the event horizon itself or in the subtle quantum correlations of the outgoing radiation. But a complete, universally accepted resolution is still elusive. Cosmic censorship, nature's modesty. The troubling nature of singularities. These points where our laws of physics break down led physicist Roger Penrose to propose the cosmic censorship hypothesis. In its weak form, it suggests that all singularities formed from gravitational collapse must be hidden from an outside observer by an event horizon. In other words, nature censors these naked singularities, preventing us from seeing the breakdown of physics directly. If a naked singularity, one not clothed by an event horizon, could exist, it would pose profound problems. Its effects could propagate out into the universe, potentially leading to unpredictable and chaotic behavior, as the laws of physics as we know them wouldn't apply there. The universe, it seems, prefers to keep its deepest, most problematic secrets hidden behind the one-way veil of an event horizon. But is this hypothesis universally true? Could there be conditions under which a naked singularity might form? This is still an active area of research. Conclusion: the edge of knowledge. So what truly lies beyond the event horizon? A singularity as predicted by classical general relativity, a gateway to a white hole or a wormhole, or something entirely new, governed by the yet-to-be-discovered laws of quantum gravity? The honest answer is, we don't definitively know. This region is forbidden, not because of some cosmic decree, but because it represents the very edge of our current understanding, a place where our most trusted theories begin to falter and new ideas are desperately needed. Black holes are not just cosmic vacuum cleaners. They are theoretical laboratories for pushing physics to its absolute limits. They force us to confront the deepest questions about space, time, information, and the ultimate fate of matter. The quest to understand what lies beyond the event horizon is a testament to human curiosity, driving us to explore the most extreme and mysterious corners of our universe, even if only through the power of mathematics and thought experiments for now. What are your theories? What do you imagine exists at the heart of these cosmic behemoths? Is it a point of infinite destruction, a portal, or something even stranger? Thank you for joining us on The Cosmic Question as we've peered into the abyss. We hope this exploration has sparked your curiosity about these incredible objects and the frontiers of science. Until next time, keep questioning.